Okay, I'm going to do one quick ballistic pendulum example. Okay, so this is our scenario where we've got a block that's hanging, and we're going to fire a dart into the block. We want to try and find out what the initial velocity of the dart is. That's what we don't know. Okay. And we're going to use conservation of energy and momentum to help us get that. So our kind of ending picture, I guess. Once the block and the dart are combined, okay, this has risen up a height from where it was originally. That's not a great drawing, but when we start off, we're going to start off with conservation of energy. And when we do conservation of energy here, we're picking our beginning and ending points very carefully. Okay, so our beginning point is just after the collision. We don't want to include the actual collision event itself because we know kinetic energy isn't conserved for this type of collision. This is an inelastic collision. So we're going to consider energy from like the moment that the two have combined and they're moving. So they've got kinetic energy at that point. And then we're going to consider our final point to be when the block has raised up to this maximum height that it's going to hit. And it'll pause at that point just, for an instant before it starts like swinging back down. When it pauses at that point, it's not moving anymore. So it's got gravitational potential energy because it's at a height. So, and I've got a couple of masses written here and a height. Like, actually, this is, I need to subtract the base height from this. So we're going to use a height of 0.4 meters for this scenario. Okay. This is one that I picked from the online simulation that I showed y'all the other day. I just kind of set it up from that. So, okay, so kinetic energy, 1/2 m. For m, we've got to add both of these. Okay, so we're going to have 4 plus 0.075. So this is the mass of both times v squared of both. And we're solving for that in this first part here. And that is equal to, again, the mass of both times g, 9.8, times my height. I'm going to use this 0.4 meters. So these are just my two equations for kinetic energy, 1/2 mv squared, and gravitational potential, mgh. So now I'm just going to do some math. Some calculations. 4.075 times 9.8 times 0.4 gives me that. I'm going to divide that by the stuff on this side so I can get velocity of both by itself. So I'm going to divide by 0.5 times 4.075 gives me 7.84. I got to take the square root of that so I can get velocity. Very important. Don't forget your velocity here is squared, so you have to deal with that. So I get 2.8 meters per second for the combined velocity of both of them. That's after they've collided. And then I can use that in my second part where I'm going to consider conservation of momentum. Okay. So now I'm going to look at my inelastic collision equation. So for conservation of momentum, we've got a before the collision and after. We know that momentum's conserved because these two objects are colliding with each other. There's nothing else interfering. So before the collision, we're going to have the mass of the dart times the velocity of the dart plus the mass of the block times the velocity of the block. And then after, we're going to have the mass of both, and they're going to be moving together at a final velocity. Okay. Okay, the block starts off at rest, so we can call that 0. That's helpful. So we've got 0.075 kilograms for the mass of our dart. We're solving for its initial velocity, and that's equal to 4.075, which is my mass of both, times 2.8, which was my velocity I got up here from conservation of energy. That's my combined mass of both. So again, I'm going to get my calculator. 4.075 times 2.8. I'm going to divide that by 0.075, and I get 152 meters per second. It's pretty fast. And if this is something that's fired from a device, then you might expect the velocity to be high. So I think that's probably a reasonable answer. So really important things here are we're picking specific points where we're looking at before and after so that we can use conservation laws. And then we're using the appropriate equations. And after that, we're just filling in values. You really got to have your givens as the masses and then the height. Or you could get that experimentally, which we tried to do yesterday. But either way, you need those items, and then you're solving for velocities. So you're solving for the combined velocity of them both first, and then you're using that in the conservation of momentum equation. And you're solving for the initial velocity of the dart finally. That's what we want. And so we get to that in our final step. So hopefully that helps just give you another walkthrough of the ballistic pendulum.